intestine, large intestine, and then pancreas and liver. Because so yesterday we left the stomach and we jumped into duodenum. We kind of looked at it briefly, but a lot is happening in duodenum. So okay, so the small intestine. Remember these ratios 1, 3, 5. Those are ratios of the lengths of duodenum, jejunum, ileum. So DJ. So duodenum first, jejunum, ileum. Duodenum is shorter, so it's a length of 1, 3, 5. So jejunum is 3 times longer, and then duodenum is 5 times longer than. Ileum is 5 times longer than duodenum. So those are, and it's pretty much throughout the entire mammal world. All mammals have that ratio. Kind of cool. So we're jumping into duodenum. So we've gone from, again, pH in the stomach is basic or acidic? Acidic. Duodenum is going to be basic. So we're going to have to jump up that neutralize, if not make it a slightly more basic environment from a pH of 3. So that's quite a job. And that's thanks mostly in part due, well, first of all, we look at the Brunner's glands, remember, in the submucosa of duodenum. These byproducts that help neutralize acids. So does the pancreas. The pancreas actually produces a majority of the bicarbonate to again, neutralize and convert the environment to a more basic environment, because all those pancreatic enzymes, there's a whole list of them. I think that in Blackboard you can see there's, and also in your textbook, you can see there's just a whole mess of pancreatic enzymes, but they function under a basic environment, not under acidic. And that all gets injected into duodenum through the ampulla of Vatar, V-A-T-A-R. Vatar, no, Vatar, I think not. Ampulla of Vatar, and the sphincter of Oddi is the one that kind of gets released or seals up and releases those pancreatic enzymes. Again, you have to memorize those words, Vatar and the Oddi. They're named after people. They have there's no other way of memorizing. Sorry. It should just go away with naming things after people. It just doesn't go. So here we have pancreas, very glandular, pancreatic ducts. This is the main one. This is ampulla vator, not this. This is the accessory ampulla. This is the main one that we want to talk about. So that all goes dumped into duodenum. And you see those folds and ripples in the small intestine. Those are called plica circularis. In the stomach, we have rugae to increase surface area. But in the small intestine, we've got plica circularis. So you can imagine, so like this piece of foam, fold it over like this. So you can see like a cross section of plica circularis. So imagine this as a ring and these folds and throughout your small intestine. And on these folds are the villi. So these little bumps are villi, and then on top of the villi are the microvilli. So you got microvilli on villi, villi on plica circularis, and the plica circularis just coat the entire small intestine. So that's how you get that crazy surface area of a double tennis court in your small intestine. That's our high-tech foam model. Yeah, so that's small intestine. So we got duodenum. Then we go to jejunum. Problem is, there's really nothing defining jejunum. We can't really tell you exactly where it is. It's somewhere in here. At this point, we can't get Catholic, as Dr. Stevens says. I mean, sometimes they say, oh, they divide it as a diagonal, and anything above it is jejunum, anything below it is ileum. That's still not exact. So we can't correctly identify jejunum. Which means on the exam, jejunum will most likely be a false statement. Right? And then ileum. But we know where ileum is because ileum is at the end. So duodenum's at the beginning. So we know we go from the stomach. This is the stomach duodenum junction, or the pyloric sphincter. Here we've got ileum, and then this is, here we have ileum. This is emptying, you see the plica circularis, emptying into the large intestine. But it's been cut away just a bit, so we can see this is cecum. So we have ileum, it's the end of small intestine, beginning of large intestine, and cecum. So it's called the iliocecal junction, and we'll take a look at that histologically, how they look different. So we go from ileum to cecum, iliocecal junction, stemming off of cecum. This is a bag-like structure. What you can see here, this is appendix on this model. This represents appendix, which has certain functions still being debated, but yeah, you can read up on it, and they still really haven't concluded prior to that. But we do. So it's right here. This is cecum, first part of large intestine, and then we've got ascending colon. So for the large intestine, it's divided into ascending. We've got ascending, it goes up, ascending, then we've got the transverse, it cuts across, and then descending colon, which drops down, descending colon. So it kind of forms a frame around the small intestine, and each of the corners are called flexures. So this corner is called a flexure right here. And it's near the liver, so it's called a hepatic flexure. The other flexure, where it kind of turns and drops down, is near the spleen, so it's called the splenic flexure. So hepatic flexure, splenic flexure. From the splenic flexure, we have the descending colon. And then underneath all this, we can't see it. On some of the models, you might be able to slightly see it. It does this, forms this S shape, so that's called a sigmoid colon. And the sigmoid colon drops into rectum, and then from rectum we end up with anus. And here we have anus. Anus is more like, so there, at this point there's no more absorption taking place, or at this point the epithelium, we've transitioned out of simple columnar back into stratified squamous. So the way to remember it is it rhymes, anus squamous. So yeah, because it's like skin again. So remember in the esophagus, it was stratified squamous. Also in the anus, it's stratified squamous. However, here it's keratinized. We start out non-keratinized, but we end up keratinized because that's the exterior at this point right now. So it needs more protection. Large intestine, some other structures on it. You see these bumps? These are called haustra. H-A-U-S-T-R-A, haustra. And they allow for expansion, so it's kind of like an accordion. So when it's processing larger amounts of stuff, you all know what it is. It allows for more stretching. Haustra. And also, you've got this band. You've noticed this grayish band running up and down along the whole length of the large intestine. That's called the there was on your word list. It's called Pt2 coli. Pt2 coli, and that's just a strip of smooth muscle. So you know how and that's what allows for that rhythmic movement of the feces throughout the body. So that's Pt2 coli, that rhythm-like structure. Yes.
At what point is kind called bowel?
Is what?
Is kind called bowel?
Chyme is only in the stomach.
Okay, so.
I believe. At this, it's in the large intestine. Large intestine really, we'll look at it histologically. There's very little absorption taking place at this point, maybe some water. So small intestine is all about absorption of nutrients and water and taking that to the body. Large intestine, you'll see it has a lot of goblet cells, so it secretes mucus. So it's all about lubricating the stool. So it makes, which allows But yeah, so it's, that's the main function of the large intestine, is to allow for that stool that's now been dehydrated, and it's, it allows it to pass easy. So that's that model. Pancreas real quick. In your netter, there's some nice diagrams. Don't forget, I guess here it's plate 280. There's a really neat diagram showing you the workings of the gallbladder, because it can be kind of tricky. So the trickiest thing, and the one thing that trips up most people on the exam, is true or false, the gallbladder produces bile.
False.
False, right? Why is that false?
It just stores.
Yeah, it's just a bag, it's just a balloon, it's just a storage area, it's just a bladder, it stores bile. Who makes the bile? The liver, right? The liver makes bile, and it just gets stored in the gallbladder. And bile is a pretty neat substance, or it's a combination of different pigments, a red and a green pigment. What happens when you mix red and green? Yeah. Sorry for that image. But that's part of the reason. But what they do is they emulsify fats. So fat is a very hard substance to digest. It's just very clingy, and it's just a very hard substance to break down. What the bile does, it gets in and it emulsifies. It turns it into smaller droplets. So like, you know, when you're washing the dishes and you have all that grease on the pan, you just put a few drops of detergent on it and it just kind of, boom, see how it breaks it apart into tiny little particles. That's what bile does. It emulsifies those fats, turns them into smaller droplets, smaller particles, so that the pancreas can more easily digest it. That's what bile is. So it's stored in the gallbladder. It's produced by the liver. So we'll trace the path of the bile from its production to its release. So produced in the liver, and it's draining from the liver through the right and the left hepatic ducts. They're called hepatic ducts because they're still within the liver. So we have left and or right and left hepatic ducts. They empty into the common hepatic duct, and then from the common hepatic duct, we need to get into the gallbladder. So we follow the cystic duct into the gallbladder. Cystic refers to the gallbladder, means in this sense refers to the gallbladder, and it enters and it gets stored in the gallbladder. And there's some really weird structures in it that sound a lot like the stomach. You know, like you can see here, you've got the fundus. You've also got rugate and bumps and ridges in the gallbladder, just like the stomach. Right? Kind of neat. Anyway, so it gets stored in here, and when it gets time to be used, it heads back out. The bile heads back out through the cystic duct. So it's a two-way street. Heads back out through the cystic duct into the common bile duct. Now, the common bile duct empties into the duodenum, just like the pancreatic duct. Together, the common bile duct and the pancreatic duct empty out through the ampulla of Vater. It is ampulla of Vater, or hepatopancreatic. So that's where it exits. So it leaves out and enters the duodenum. So it all starts. So we can take a look at that now in the models. For the liver, we have the different lobes, right? We have the right lobe, which is larger, the left lobe is smaller. And then we have 4 other lobes in the human liver. We have one that's very squarish, so it's said to be a quadrate. Quadrate is near the gallbladder. So quad, you think of 4 sides, a quadrate lobe, and another one, caudate, which is kind of tail-like, so it's called caudate. Caudal is the root word, and it runs up and down next to the inferior rib. stores bile. So we'll see, yeah, you know what? That one's kinda neat. Yeah, this is. Yeah. So we'll take a look at this one. We'll zoom in on some certain structures. Everything's like professional, so I will figure it out. There. So we have the left and right hepatic ducts, empty into the common hepatic duct, empty into the cystic duct, gets stored, heads out back to the cystic duct, and then out through common bile duct. This exit. So here we can see common exiting out through common bile duct. So cystic duct, common bile duct. You can kind of see the hepatic ducts, they're deeper down. And then hepatic portal vein, hepatic artery, branching off the hepatic artery, cystic artery should be part of the answer on the thing last week. So that all empties into common bile, heads out through common bile duct. Common bile duct empties into, let's zoom out, get a bigger picture. So this is duodenum, right? Because we got all the neat plica circularis. This is ampulla of the vater, or the sphincter bodi. And you can see where the common, this is the accessory one, so don't worry about the accessory. Focus more on this one because this is again where the common bile duct empties into, and so we've got the common bile duct coming along here, emptying into ampulla vater, and the pancreatic duct emptying into ampulla to one. See on the backside too, a bit of the common bile duct. Bile duct is always going to be green. They color it green because it does tend to have a greenish